Okay, next we'll be looking at how we can graph the reciprocals of the sine, cosine, and tangent. And to graph them, we are going to use a model of the actual trig function sine, cosine, or tangent to help us with graphing the reciprocal. The secant is what we're going to look at first. Secant goes with cosine, so secant kind of models after a cosine function, but we have to kind of keep in mind how these reciprocals work, and then we're going to have some interesting things that are happening. Cosecant is going to model after the sine, which will model where sine is, and then how cosecant is the reciprocal of that, and then cotangent is kind of its own little beast too, same as tangent. So it looks very similar to tangent, and we'll see pictures of that in a second. Secant and cosecant. These graphs are sometimes called the drunken horse, and you'll see why in a second, why they're called that, because you will see some horseshoe type shapes here. But let's get our graph set up. We're going out to 2 pi, so I'm just going to leave that there for right now. When we're graphing a secant, we are going to look at a model of its reciprocal. So we're going to look at cosine 2 theta to help us get started here. Now cosine 2 theta has a couple things going on. The a is going to equal 1. The b is going to equal 2, which means my period, I'm just going to call it p, is going to be pi. So that is kind of starting out looking at the cosine of 2 theta to get this graph started. All right. 2 pi is right there. We'll go halfway between. There's going to be where pi is. And then pi over 2. And 3 pi over 2. Now I'm going to have 2 cycles between 0 and 2 pi. That's what this b value is telling me. So I'm also going to include pi over 4 units. I'm not going to write in all of them, but there's where my pi over 4 units would be. Okay. Then on my y-axis, I'm going to draw my amplitude. My amplitude goes from 1 to -1. I'm going to leave a little space because actually my secant graphs are going to be up in this area. So I want to leave some space on my y-axis to show those. All right, so if we are looking at cosine points, and I'm going to make them in blue here, the cosine points would be right here. Starts at 1, goes to 0. So these are those first 5 main points we're going to be graphing. And then one cycle is going to finish right at pi, right there. Then our next cycle, we're going to go back to 0, down to the minimum, back through 0, and then up to the maximum. So roughly that's what my cosine graph is going to look like. Now I'm not going to graph the cosine. I'm just kind of using the cosine as my model. Now let's take a look back at the unit circle, which I got to find. I thought I had that up there. Hold on a second. So the unit circle, when we look at secant is 1 over the x-coordinate. So right here, where x is 1, 1 over 1 is still 1. When you get to this position on the unit circle, you're now at 1 over 0. And you can think, what happens when you divide by 0? You get undefined. And anytime we've gotten undefined, where we saw that in chapter 8, we've also seen it with tangent when you're doing your y over x. You are going to get asymptotes. So right there is going to be an asymptote. So where x is 0 right here, there's an asymptote. Here, x is -1. 1 over -1 is still -1. Here, where x is 0 again, 1 over 0 is undefined. It's pretty simple to see on your graph where x is equal to 0. It's all these points that are right where they're crossing the theta axis. Right here, right here, right here, and right here. those are going to be your asymptotes. So wherever your cosine graph crosses that x-axis, that's going to cause, in your secant graph, that's going to cause asymptotes. So we're going to draw asymptotes at those positions. So there's 1, 2, 3, 4 total asymptotes. Because when I do 1 over x at those positions, since x is 0, that's going to cause asymptotes. Then, when you are doing the reciprocal of each of these values on the unit circle, they are going to all be greater than 1, and they're going to approach infinity. Like, for example, if I was going to do the reciprocal of this x-coordinate, the reciprocal of this x-coordinate is 2. If I would go up to an x-coordinate that's very close to 0, if I divide by a very small number, that's going to increase that value all the way up until I get to infinity, until this asymptote where it's undefined. So when I'm drawing my graphs, and this is not anything that's too scientific, you're going to draw your outputs of your secant approaching the asymptote. So that's going to approach the asymptote there. This one's going to face down, approaching the asymptote, approaching the asymptote. This one's going up, approaching the asymptote. And this one's going down, approaching the asymptote. And then this one, we can go back towards the asymptote this way. So it's called the Drunken Horse graph, because if you think of these as horseshoes, and this horse is just kind of wobbling around with its feet out, that's going to be the shapes of our graphs. We're going to see these U shapes approaching those asymptotes at all those points where the cosine graph would have been equal to 0. Now, a little bit better picture I can show you is on a program I like to use called Desmos. So there's our cosine graph. So we modeled those first couple of points of this cosine graph. If I graph that secant graph, you can see from 1 it approaches those asymptotes, and you can see all those asymptotes are right where the graph is crossing the x-axis. So there's an asymptote, there's an asymptote, there's an asymptote, so on and so forth. So wherever those values are equal to 0, those are where you're seeing those asymptotes. But if you're looking to see a nice clear picture of some of these, Desmos works very well. You can just type in SEC2x and it'll graph secant 2x. You can graph cosine 2x. You can start to see those graphs in a nice picture. All right, now we'll head into cotangent. So cotangent is also kind of its own little beast, but let's take a look at cotangent. Cotangent, I'm not going to use tangent at all. I'm just going to kind of use the definition of x over y. So we got to keep that in mind. Cotangent is x over y. In this one, my a is equal to 1. My b is going to equal to 1. My period is going to equal pi over 1, which is just pi. And lastly, my asymptotes. Here, your asymptote's always going to start at 0. So with cotangent, your first asymptote is always equal to 0 plus every period times the number of cycles that you do. So here it would be 0 plus pi n, because my period is pi. So why is that first asymptote always going to be 0? Well, let's take a look back at your unit circle. Right at this theta equals 0 position, if I do x over y, what's going to happen when I do 1 divided by 0 every time? 1 divided by 0 is undefined. And then I'm defined until I get to pi, where my first period goes right to here. Now I'm undefined again. So my asymptotes for cotangent always going to be that y-axis. It's going to be that first position there. That's always going to be an asymptote. And then every period after that will be an asymptote as well. So when I'm looking at graphing this one, we'll fill in our values: 2 pi, pi, pi over 2, and we got our 3 pi over 2. Okay. Now we draw in our asymptotes. Asymptote is going to be at 0. Right right there, and then every period after 0, so that'd be at pi, my next one, and 2 pi, my next one. Okay, tangent, just really quick, don't graph this. Tangent, we started along the negative asymptote, went up to this positive asymptote, started here, went up. Well, now that we're doing the reciprocal of tangent, that is going to flip my graph. So cotangent, we're going to start on this positive, heading down to this negative asymptote. And I didn't quite get close enough to that asymptote, but you'd want it to be a little bit more like so. So there would be your cotangent graph. So the big thing with cotangent is your first asymptote is always going to be at 0. And then each period after 0, you're going to have a new asymptote. So you can add on however many periods you're graphing, you can add on an asymptote every length of a period. Okay, and we'll finish up then with y equals cosecant 2 theta minus 1, which we're going to look at this graph. Y equals sine 2 theta minus 1. So we have that k value, which is going to bring us down -1. So here's going to be our x-axis we're going to kind of use. So our x-axis shifts down. Other things about this, your a is going to equal 1. Your b is 2, which means your period is pi. So period is going to equal to pi. So we'll start making our labels. So there's 2 pi. There's pi. And we'll go halfway between pi and 0 is pi over 2. And 3 pi over 2. And in between then, because we're graphing 2 periods, 2 cycles, I should say. So that's going to bring us to those intervals. So now we'll graph what our sine would look like. Remember, sine always starts at 0, so I'm going to start shifted down 1. I'm going to start right here. Then it's going to raise 1. Then it's going to go back to 0. And I probably should mark where -2 is, because it's got an amplitude of 1. So it's going to go from 0 to -2, high and low. So then at this position, we'd be at our lowest point, and then back to 0. Then we're going to be at our maximum, back to the axis there, lowest point, back to middle. So if we are looking at the sine, this is what that sine graph would look like. But we are now more interested in the cosecant. Now this is my new x-axis along here. This down here is my new x-axis. So wherever these points are hitting at 0, that's where my asymptotes are going to be. So that's those points that are undefined. So I'm going to have an asymptote right along the y-axis. Asymptote at this position, pi over 2. Asymptote at pi. Asymptote at 3 pi over 2. And an asymptote at 2 pi. Then I'm going to start drawing my horse, and to try to get those to stick out a little bit, I'm going to use green. So there's my first curves heading towards the asymptotes, second curves, third curve, and since we have a total of 2 cycles, you're going to have 4 horseshoes. There they are. So there would be your cosecant. And inside of here, just to kind of visualize again, there's where your sine is. And then your cosecant is going to be the reciprocal of that. So finding all those asymptotes and then drawing in those horseshoes is what you'll see. All right, hopefully that helps with graphing. Also recall you can use Desmos. Desmos is a very nice tool to use, very clean. So you can kind of see a picture of it as you're practicing your secants, cosecants, and cotangents.